Data distributions. What is a data distribution? Data distribution is the distribution of a statistical data set or population is a listing function showing all the possible values or intervals of a data and how often they occur. Here is an example of data distribution.
That's why I don't want to put it in.
Oh, didn't mean to do that. Scatter plot. A scatter plot is a graph in which values of two variables are plotted along two axes, the pattern of resulting points revealing any correlation present. Here is an example of a scatter plot showing a positive correlation. Histograms. A histogram is a diagram consisting of rectangles whose area is proportional to the frequency of a variable and whose width is equal to a class interval. Here is an example of a histogram. Box plots. Box plots are a graphical rendition of statistical data based on the minimum, first quartile, median, third quartile, and maximum. And here is a fine example of a box plot. Tally charts. Tally chart is a table with tally marks to show the value data set. An example. Venn diagram. A Venn diagram is representing the mathematical or logical sets pictorially as circles are closed curves within an enclosing that common elements of the sets being represented by the area of overlaps among the circles. And here is an example of a very complicated Venn diagram. Pie chart. Pie chart is a graph in which circles divided into sectors, each represent a portion of the whole. Here's an example. Line graph. A line chart or line graph is a type of chart which displays information as a series of data points called markers connected by straight line segments. Here is an example of a line graph. Trend charts. They are also known as run charts and are used to show trends and data over time. All processes vary, so single point measurements can be misleading. And here is an example of that. Bar graph. Bar graph is a diagram in which the numerical values of variables are represented by the height or length of lines or rectangles with equal width. Here is an example of a bar graph. Pictograms. Pictograms are a pictorial symbol of a word or phrase. Pictographs were used in the earliest known form of writing. For example, have been discovered in Egypt and Mesopotamia before 3000 BC. Here's an example of a pictogram. Triangle chart. A triangle chart is a technical chart or pattern created by drawing trend lines among converging price range variations. Variations of a triangle include ascending, descending, and symmetrical triangles. Here is an example. And here is my MLA source, and that's it. Next person.
Would be Mason.
Is he there? Oh.
Mason, you're muted as well.
How about now? Oh, sorry. Can you hear me?
Yeah.
All right, you ready?
Yep.
How do I make this full screen? Like right here.
Go.
Bottom right. Yeah.
Right, got it.
Like the little pull down thing that looks like a, well, 2 over. Yeah. Go. Nope. Right there. Nope.
Whoops. Sorry, guys. This is unprofessional.
It absolutely is.
First attempt, it's okay.
It's the little symbol to the left of the 60% thing. Yeah.
This one.
Nope. There.
Okay. Got it. All right. All right. Standard deviation and the bell curve. What is the bell curve? Bell curve, or what the statisticians call a normal distribution, is commonly seen in statistics as a tool to understand standard deviation. Below is the formula used that can be used to solve and express any bell curve as a function of x. Properties of a normal distribution. The mean, mode, and median are all equal. The curve is symmetric at the center, i.e. around the mean. Exactly half the values are to the left of center, and exactly half the values are to the right. The total area under the curve is 1. Standard deviation. Standard deviation is used to calculate the bell curve with these following steps. Number 1, work out the mean, the simple average of the numbers. Number 2, then for each number, subtract the mean and square the result. Number 3, then work out the mean of those squared differences. Number 4, take the square root of that and we are done. And that is it.
Okay. I will pull mine up then. 1 second. Okay. Can you see my screen?
Yep.
Yes.
Uh-oh. I don't think I started at the beginning. Okay. This presentation is about what bias is and why it is important to identify it before believing statistics. Let me pull us up here. This is all about why you should research more before believing statistics. Bias is defined as prejudice in favor of or against one thing, person, or group compared with another, usually in a way that is considered to be unfair. We see bias everywhere, as I am sure all of us are aware, most notably in news outlets who have a political agenda. Why is it important to identify bias? It is important to get the whole story, not just one side. It's like a court case. The judge and the jury must hear both sides of the story in order to fully understand the case. If the judges or jury find themselves choosing a side out of personal beliefs or because they simply don't like one of the defendants, they must recuse themselves so there can be a fair trial. It should be the same with all of us when we are researching a topic or simply want to understand something better. Always go to multiple outlets and get multiple sides of the story. Look at as many studies as you can so you can get a clearer picture. Don't just take one person's research as a complete fact. Do some research of your own if possible.
Okay. So the remainder is what I will finish. Okay. So let's see. Okay. Can y'all see mine?
Yep.
Okay. Okay, so the types of bias. There are quite a few. Let's see. Oh no, I skipped it. Okay, here we go. So here's some examples. So misleading graphs. So up here you have the most common trick to graphs is to not start it at 0. So here's a few here. And then the types of bias and sample surveys. So like sampling one area and not the whole, not a random sample can affect the outcome. So it's good to have like a broad audience and not just a selected amount of people. So what can be done to minimize statistical bias? Check and double check your methodology for creating accurately representative samples while considering the the launch of new research project. And then here's some types of bias. It's like selection bias. So that's kind of blurry, but information bias. And then kind of like what I was talking about a second ago, you see the airplane over here where, like, depending on the angle you're at, it could be totally different. So, and then always ask researchers who find their studies where they get it from. So stuff like this, like Coca-Cola or whoever, you know, because you don't know what they could be doing, hiding or bolstering numbers or whatever. So that's really it.